Good afternoon and good morning, everybody, depending on where you are, of course. I'd like to welcome everybody to today's presentation. I think we've got a great one for you. I'd like to announce the Ontario Public Works Association Right-of-Way Management Committee is pleased to announce that going forward, it will be linking arms with the American Society of Civil Engineers, Utility Engineer, and Survey Institute, known as UESI. The Ontario chapter is to co-host the annual Right-of-Way Management Conference moving forward. And before I go any farther, my name is Mark Kavanagh. I am with T2 Utility Engineers and also the acting secretary of the Ontario Public Works Right-of-Way Management Committee. For those of you who may not be familiar with UESI, I invite Blaine Hunt to briefly speak on who they are and why they've joined the OPWA Right-of-Way Management Committee to host the 2020 Right-of-Way Management Webinar Series and future conferences. Blaine?
Thank you, Mark. My name is Blaine Hunt. I'm one of the co-chairs for the American Society of Civil Engineers, Utility Engineering, and Survey Institute. I also happen to work with Mr. Kavanagh at T2 as well, so I can speak to his involvement. Just for those of you that don't know, the Utility Engineering and Survey Institute, which is known as UESI, is a branch of the American Society of Civil Engineers. And aside from being responsible for the engineering standard within our industry, which is the ASE 3802, UESI also has a vision to be a worldwide leader generating products, services, and promoting excellence for utility infrastructure. The Ontario chapter that I'm a part of was founded in December of 2018 along with our board. And UESI Ontario was the first Canadian chapter within the UESI under the ASC branch. UESI is proud to become a co-sponsor of the 2020 Right-of-Way Management Conference and beyond. We felt this was a great opportunity to join with the OPWA Right-of-Way Management Group. We have similar goals and objectives. We think that we can increase some of the exposure related to our members in Ontario and our other chapters across Canada and the US. We also want to strengthen an already established successful conference. We all recognize that this conference has been a great product in the past, and we know it's going to be even stronger in the future with our help as well. And Jen, just a thanks to the OPWA and the Right-of-Way Management Conference for allowing us to be part of this and helping out, and everyone enjoy the webinar.
Thank you, Blaine. Thanks for vouching for my participation on the committee as well. So the OPWA Right-of-Way Management Committee and UESI is jointly announcing that starting in 2020 and going forward, October will be designated as Right-of-Way Management Month. The intent of Right-of-Way Management Month is to promote and to bring greater awareness through education to the many challenging issues associated with the management of the public right-of-way. For October 2020, free educational webinars like this one are offered every Tuesday and Thursday. You can visit rightofwaymanagement.ca, as you probably have, to get signed up for this webinar, to learn more about future webinars and get signed up for those as well. A few housekeeping items. The Right-of-Way Management Committee is always looking for industry involvement. If you're interested, please email info@rightofwaymanagement.ca. We're always looking for volunteers and for different opinions, points of view. And prior to starting today's webinar, I'd like to go over a couple housekeeping items. All delegates are muted throughout the entire presentation. There will be a question and answer tab at the bottom of your screen. It might be off to the side, I'm not entirely sure. But if you have questions, please type them in and do not use the chat tab if you would mind. I'll go through the questions at the end of the webinar and pose them to our speaker. This webinar is also eligible for the OASET CPD program as a partial 1-hour fulfillment of the full-day informal course self-directed study. A proof of registration, a short summary of what you learned will need to be submitted to OASET for the webinar to qualify towards your CPD. This information will be available on our website at the end of the week. Today's presentation, I'm glad to announce, is MultiChannel GPR applications for your project. Today's presenter is Mr. Jamie Bradburn of T2 Utility Engineers. Jamie is a leader in utility engineering and surveying with more than 17 years of work experience and is an experienced trainer for different geophysical techniques, including utility locating. As a field operations manager at T2 Utility Engineers, he's responsible for the overall field operations, planning, training, and project management of projects for SU services. Jamie, the floor is yours.
Thanks, Mark. I appreciate that. It's a very nice opening there. I'm just, I've been on a few of these, but trying to figure this out. Hey, Mark, it's not letting me share the screen.
Okay, I've stopped sharing, Jamie. That should work for you.
Perfect, thank you. Maybe you can just jump in, Mark, when you think you can see it there.
We can see your smiling face now, Jamie. Not sure, maybe it's on the wrong screen.
Try this again. Same?
Same.
Well, at least you get to see me, I guess, throughout. Why was it working a minute ago? Let's do this. Anything?
Nothing yet.
I'm trying.
Okay.
Nothing yet, I guess, eh?
Nothing yet, Jamie.
Mark, I'm sorry.
It's okay.
Jamie, if you want to email it to me, I can bring it up.
Okay, yeah, okay, give me 1 second there, I'll do
Or
that.
to Steve or even Mark. Yep.
Yeah, or show me where it is on the server.
Yeah. Hey, Mark, can you even see a black screen at all?
I can see a black screen with your name on it.
I don't even know what screen it's showing.
There we go. Something's happening. There we go, Jamie.
There we go. Thank
Take it
you.
away.
All right, I'm going to try here. Well, I appreciate it, Mark. Thanks for all that. And sorry, everybody, it takes a bit of time. I've done a few of these. I've been on a few of them, but haven't done one yet, as you can tell myself. So it takes a little bit to get into. So I appreciate everybody registering and joining in today. And I hope everyone's staying safe, especially in this world that we live in right now. And that y'all had a good weekend. I know for some, maybe we got together with some people and had a good weekend. So let's hope that we all did that. I typically like doing these presentations in person. I kind of feed off the crowd and kind of go with it like that. So hopefully this comes together as a good virtual presentation. It's a little different not having everybody there and answering questions and seeing people's faces, but I'll do the best we can. So I'm here to kind of discuss multi-channel GPR and some applications that you can utilize for your different projects that you'd have. And I was trying to figure out where to go with this and how to go. So at the end of the day, I think I'm starting off just what is GPR? I know that we've all probably heard it or maybe seen it in the past, but what is GPR? Kind of go into some real 2D real-time interpretation, kind of then how we switch over to do different arrays and different ideas of GPR systems. Then how we're kind of trending away from the single channel into more of the multi-channel. I'll actually talk about the multi-channel GPR itself, and then I've got some actual project data that I wouldn't mind going through and kind of showing you and go from there. So hopefully it works out well and I've got the kinks worked out now. So where to start? What is GPR? Hopefully some of you have heard about this, maybe seen it, heard about it, understand it, but at the end of the day, GPR is ground penetrating radar. Hopefully we've heard that. It's a non-invasive electromagnetic geophysical technique, as you can see in the picture. They're usually smaller systems that you can push in the past. It's really all about the reflections that you receive back. There's a transmitter and receiver in the system. transmitter sends out a pulse, the receiver receives that, and the data is interpreted on the screen. It's really good because it can find metallic and non-metallic utilities or infrastructure that's in the ground. And it's funny, I always look back at these pictures and say, for anybody that's seen it or used it, it's always the people in the public comment, oh, look at that nice fancy lawnmower that you have, or have you seen any gold yet? And if you do, you've got to share. And I'd like to say maybe we should put a lawnmower in the back of these things, is the amount that we're pushing them out there. But that's kind of the system. That's what we've used in the past, and we still use it to this day. They're very good. There's all different types of models. They're all changing all the time. But typically they're a push system where the data is collected and usually interpreted real time, just right in the field. So as you're pushing, if you saw something, the data would be interpreted there and kind of looked at right in the field. So like I mentioned, it goes through and does metallic and non-metallic infrastructure, natural man-made underground features it can pick up, which would include utilities, which are a big portion of what we do, but also storage tanks, rebar, sinkholes, voids. If you're looking for water table or any environmental contaminants, buried artifacts, grave sites, pretty much anything that's kind of subsurface or in the shallow subsurface that we can do. And like you can see there, there's some pros. It's nice that we can utilize it for non-conductive pipes or utilities. You can actually get a very accurate position and depth of that information. And it's good for mapping. It's overall mapping of utilities. But some of the cons with the smaller systems or the push systems that we would use is the dimension and weight. Sometimes if you're pushing these systems all day, or you can see in the picture in the winter there, the systems can get fairly big. They're very heavy, and dimension-wise, or how much data you can collect. You definitely need to be a trained person to operate it, especially with the interpretation that takes place in the field. And usually it's more expensive technology, so you wouldn't want to just to get it for, we use it typically every day, but for some people, it just might not be what you'd want to get. So kind of this is the standard 2D GPR that we'd use on a day-to-day to help us find utilities or underground infrastructure. So I'm just trying to replicate here is just some of the fundamentals of GPR, because what this does is we utilize this all the way through for our single channel, multi-channel, from our mapping purposes and how we do it. And I kind of wanted to give everybody a bit of a background just in GPR in case you hadn't heard it or have seen it before. So as you can see, it's typical push model is you push the GPR system across the ground. Sometimes it's very easy on flat surfaces, but other times it can be very difficult. And as the transmitter sends out its signal and the receiver receives the reflections back, as you slowly come over the utility or whatever you're looking for in the underground, it creates these waves and these markers on the screen that you're utilizing. And then as you keep going back and forth and pushing the utility and GPR, you eventually try to see these hyperbolas. And that's what we're looking at with GPR data. So when we go back to what we would use as standard GPR in the field or the everyday, it really comes down to the person utilizing the GPR and their interpretation of the data real time. So these are great if you need to do, utility locates or to help you find utilities quickly and in the field. As long as the conditions work and everything works for it, they're great for that. They're quick. You can pull it out, push it along, try to map out the utilities. But that's the data you're kind of looking for in the middle of the screen. It's these upside down hyperbolas, and believe me, if they all look that nice, it'd be great, but not typically do they do that. So it really comes down to that interpretation, and it's always been a bit of a concern when you're mapping bigger areas or in roadways where you need a bit of time for that interpretation in between cars and traffic and even pedestrians that are around you. So then again, here you can see this is some of the standard GPR data that we look at in the field or when you do it real time. This is great data. And again, I'd love to see this data all the time. It's not really the case, but to kind of show the point, if you're doing the interpretation in the field real time, you need the time to be able to look at it and do your interpretation, move back, figure out where it is that you're seeing it. And then would all these be utilities? Could they be some utilities, some buried infrastructure, rocks, anything that's in the subsurface that could give you that reflection can give you this data. So when you're in the field trying to do it real time, it can get quite difficult and time consuming to map a bigger area when you're out there doing it. So this is just the data that we're looking at. This is what we say is the GPR data, so that you kind of all have an understanding of what the data is that we're looking at. Again, it comes back that it's a bit of a slower acquisition with the normal push GPR systems. It's good for certain applications and in certain areas, maybe when there's small areas and that type of thing, but it's very prone to that interpretation. And most of the time, these are just, I would say the majority of the ones out there are used for utility detection. So from this, over the years, we've been trying to switch out and say, okay, what can we do to help us maybe gather data quicker, get more data, try to figure out what we can do. And you can see here that what we're doing is trying to go to array systems. So again, it's almost like you're taking 4 smaller GPR units out in the field and try to push it. Again, this is where it gets very cumbersome, trying to collect the data and to go with it, but it's kind of where we started to dabble in these array systems. And you can see we did it in the winter. These systems that you see here don't really like the winter temperatures very much. I think back on this day, I think this was a day that our batteries froze and the screen froze and everything else froze on us, trying to put it to the limits. But we're trying to take it a step further so we can really start to map this area, I guess, quicker and have the more information to come in. And again, here it is in the summer, same idea. You know, we're trying to expand the system into 4 systems to collect more data, maybe make it more efficient in the field and to see what we can get with it. So this is us moving from the single channel, I guess, the smaller systems more into an array system so that we can collect more data. And then from here is where we're going to go now into the multi-channel. But I just wanted to kind of give you that bit of background information on just GPR. So when I say GPR or a transmitter receiver, you have a bit of a background in the information that I'm going to be utilizing here. And like I said, if you have any questions or concerns, hopefully ask them at the end or reach out to me and I can definitely help you out or try to go through there, but I didn't want to drone on just the background information of GPR in general. I kind of want to get in what makes it exciting for me and going into the more multi-channel and how we're really utilizing this now on our day-to-day projects and maybe really where it can help out on, you know, different right-of-way information and what we can do. So kind of moving into the next kind of area now is where I'm saying trends, but where we're looking at going with it. So you can see here, it's, you know, a 3D model, there's voids, a massive amount of infrastructure in the ground. And what can we do to really help and collect this information? So with the single channel or the smaller systems, it's great for the real time. You can mark it in the field, you can put paint on the ground, you can bring that data back. You can maybe look at it and interpret it a little bit, but at the end of the day, it's really just a real-time system. By us trying to move to these arrays or these bigger multi-channel systems, it really is going to help more with, you know, in as-built situations where we're looking to find all pipes and cables, not just a singular one or not trying to find this plastic water main that's out there. We can definitely use it for utility planning, road maintenance, and even if renewal. So if you need to figure out if there's voids or how maybe deep the road base is, or if there's a concrete road base or anything like that. So it comes down to safety and if there's any cavities in the road. And then if there's any other underground assets and conditions. And this is kind of where I like to go is there's a lot of abandoned utilities out there, abandoned structures, even infrastructure like trains or old train tracks or tanks or building foundations that have been buried. All this type of stuff could be out in these easements or these right-of-ways that we have, but we don't really know about it. And our typical electromagnetic day-to-day locating techniques maybe will not find them, or they'll find them, but it's very hard to interpret what this data would be. So we're trying to take it from the one side to the other. So as part of a process, as part of a tool in our toolbox, we're really trying to bring out a different area where we can take this information. So I guess going from typical GPR and that nice picture that you saw of us pushing that small system to what is multi-channel GPR, MCGPR, as I might call it the odd time here and there. So what is it? All what we're trying to do is we're gone from this small system to maybe a bit of an array to now we have a system that is a toe behind, big system. There's different variables out there. There's smaller systems that you can push, but really what we're trying to do is get have a system big enough that we can collect all this information as we're traveling down the road, kind of in one time as we go. So in this system that you can look at here, this is a multi-channel system. It's got 40 channels, where the typical ones that you see, the small push ones, are probably 1 to 2 channels, and it has different frequency of antennas. So it's got 200 antennas in there and 600, and they're collecting data in both directions. So as this system drives down the road, we're actually collecting data in that full swath with multi-frequency antennas as well as in different directions. So the whole idea is for us to collect as we're going down the road, or in a piece of land, or wherever we're going with this, is we only have to collect data in that once going down the road. It's collecting it in both directions for us, and then we're done with it. We can turn around and collect the other side of the road. So from the efficiency in the field, it definitely picks up. We can collect a lot more data a lot faster. And then we don't have to go back and forth. With the older systems, we'd have to go back and forth parallel to the road and then across the road. So for something now we can collect in maybe an hour, it might have taken us days to collect, to try to get the same idea of data out there. So those are the bigger systems. Again, you can have GPS connected to them, which allows you real-time acquisition where you are. It allows you to take the data and put it into GPS. From the GPS, you can then put it into CAD. We can relate it to different datums into KMZ files. We can do a lot with it as long as we're collecting this. So there's a lot of information that's going on and be collected at this point in time. And then just to show you a smaller system, this is a smaller, again, multi-channel system. I think this is 32 channels, 34 channels. Again, different frequencies within there. This one's a tow behind as well. And you can push it, tow it, and collect that data with GPS and everything else. So it's the same idea. So it depends on what we're going to do. Is maybe some of the ones that we'll use in the roadway or big land areas, where these smaller systems will get us closer to buildings, or on sidewalks, or in different areas. So again, everything comes down to what the scenario holds and what you feel that you need to use for those scenarios. But the whole idea is this array of system with different multi-channels and multi-frequencies collecting, sorry about that, in all different directions. So again, what is the multi-channel? Well, it's like I've talked about, it's arrays of multi-frequencies, and I've got 200 and 600 here, but there's many other ones out there. It's a massive array compared to what that one single push one was. There's different types that can be towed and pushed, and the key information here is that you're gathering a ton of information quite quickly, and you only have to do it in one direction, where in the past we'd have to collect data in the 2 directions or multiple directions, but now we can just travel down this road and collect data as we go down. And it's the one system, the big system you're looking at there, is almost the width of a vehicle. So to do a laneway of road, now you're maybe doing 2 swaths down that road, where we'd have to do multiple in the past to do that. But then why try to do this? Why try to get this big system out here to collect data? How does it really help us? Well, I've used this slide a few times in the past, and hopefully it's working for you and you can see it. I take it back to like when you used to get an X-ray versus a CAT scan. The X-rays were good and you had to look at the information, but you had to look at it all individually and really try to relate it back and figure it out. Where if you go to the CAT scan, it's now almost like a movie of the brain, so you can really see everything. Well, that's what we're trying to do with our information. So we're really taking it from detection to mapping. So you can see in the bottom part, our typical B scans are what we normally see in the field, and that was the real-time information that you'd have to utilize, compared to now with the tomography scans. Now you can really start to see the information on a whole. And that's really where I feel that this is a huge help, because now we're looking at it on an overall, we can see different things and relate information to the other information as we go. So we're just really trying to, like always, create that clear image. I'd love to say I have X-ray vision, or people always ask if I do, to see certain things, and no, we don't, and we can't use X-ray outside. But for me right now, this is kind of as close as we're getting, or every day it's changing, but as close as we're getting to that information to really gather and see what the underground is giving to us. So like I keep mentioning, we're really trying to take it from the 2-dimensional world, or the 2D of what we normally collect, to the 3D. And what we can do with these array systems, and it really comes down to the collection part of it, is fairly simple. It's a big system and you have to understand how to put it together, but the collection of the data, because now you're not really doing the interpretation in the field, or it's not real time, you're now doing all this data post-processing. So that's where now there's definitely more time in the office than what there used to be, but the product itself is pretty amazing. So now we can go from these two-dimensional ideas all the way through to three-dimensional pipe detection or structure detection as we go, and we can create these overall tomographies as we do it. So we're still utilizing GPR data itself. It hasn't changed. We're still looking for those hyperbolas and trying to connect them together, but because we have this multitude of data, it's allowing us to create these better tomographies and this better information, actually produce this 3D information that we can then use in CAD drawings, we can use in KMZs, we can use it anywhere to create what we need. We can even put it into a GIS program for certain things. So it's really working out well, is getting all this information. And what I mean by that is what it allows us to do. Again, this is all data interpretation that we're still utilizing from these multi-channels. But now we can start to pick points. You can see the top version is the data itself. So we're still using GPR data. But with the software and the processing software, we can start to pick these points, put information, start throwing 3D and elevations as we go. So you can see here, this is a utility that's coming to a cross street. It's dipping down to get through the intersection, then comes back up on the other side. And we can start to do this and actually export this data as a 3D model. So you can see here just a basic set of information. But now we can start picking out pipes or different utilities and actually exporting those picked points out into something that's very usable, into a CAD file or into whatever information that you need to utilize it in, and really helps with the planning and processing to really know what's out there to gather that information. So it's really come a long way with that. And again, you can see here, just to try to show you the overall set of all three, is the top one is the tomography view. So you can start to see now, this might be 2 or 3 swaths, but you can start to collect the linear lines. You can have overall structure information. You can really start to pinpoint the data. The middle picture is still showing the normal GPR data, let's say, and it is what it is. It's reflections that you're getting back, but because you're getting so much of it, it really helps you collect all this data. And then the bottom part would be that 3D model that we can kind of go and push out. So you can start off with the tomography if that's what works for you, and these can be all geotipped information that can be exported out to write down to a full 3D model of what we would be finding. And again, to me, this whole part of it is a tool in the toolbox for the whole process, for the whole idea of what you're doing. So if you're doing a complete SUE investigation, it might be that you'd want to use the multi-channel to help out. Especially it allows you to get out into live traffic. You can collect data day or night. Vehicles and that type of thing don't really affect it very much. So you can really get out in this live data, this live traffic, and be safe. But there might be some other ideas where, no, you might not take it this far. But then if you're going right through to a 3D model, this really helps correlate the data and bring it back if you're doing test holes and that whole type of thing out there. So that's kind of the data set that you would see and utilize to create different things. And then I'm going to slowly go into that now. Okay, so what are we going to look at? What's the kind of data that we can receive from it? And then really what we can do with that data. I'm just going to jump in here. I feel bad because I can't see anybody's faces or understand how it's going, but I got to keep going through here and hope for the best on this. So hopefully this works. This is what we call a depth slice animation. So these are the depth slices that we can now get from using an array system. So to do this road, we did 4 swaths to collect all this data. And what we can do is as an export that goes out, we can now put all this data together. So these are data slices, depth slices as you go through. So hopefully you can see this movie, and Mark, jump in if you're not seeing it, but it should be a movie, and you can start to see as you go down through depth, you can start to pull out different utilities, different structures, and any of the information. So this is just a visual application that you can do, but having it as a whole mapping situation, tomography of that data, it makes it a lot easier to do the interpretation and to pull it together on a whole for that project. And I'll see if I can run it again now that you've seen it. So you can see as you're going through different depths, as different things come through, you can see there's trenches, there's maintenance holes, different utilities show up as crossing the road. And it really helps where in the real-time world that we used to live in, you would collect this data and you have to try to mark this all in the field, or maybe bring some of it back to do some interpretation. But now it's really all about the post-processing and really looking at this data. And to collect those 4 or 5 swaths in the field itself is fairly quick. The processing side takes a bit more, but it's definitely allows you to get way more information on that. Sorry, the same one there. And again, to try to look at, well, maybe there's some areas that the information is not very good. So what I mean by that is, if you know GPR, it can be very good in certain situations. If it's high clay or high saline soils, it's not going to work very well. Where if it's nice and sandy, it's going to work really well. So this is a situation where you come down to, for us, again, with the array system, it helps you pick this information out that you can put on a drawing, versus in the past, if I was doing the real time, one, I've having to deal with in the middle of the roads and traffic, but two, it's really hard to pick trenches and different utilities when you're out there. So this is something that we've kind of gone through, and you can see this would be a fairly shallow tomography, a section that we have a depth slice per se, and you can start to see in there, well, there's some maintenance hole covers, maybe some valve covers, maybe you can start to see certain things come through, but this is a fairly shallow depth slice. But then as you go through these depth slices, other information starts to be picked out, and you can start to see, well, there's definitely multiple trenches, there's definitely some pits going on, you can start to see here some other pits, and maybe now you're getting a full picture, where again, if this was just real time, you really wouldn't be able to see this as the information comes out. And then you can process the data and really start to figure out some of this information. So even though I'm not necessarily seeing utility specific, and what I mean by that is the actual utility in some of these cases, I can really start to figure out what we need to do. So now looking at this picture, you can see, well, yeah, there's definitely utilities. It looks like maybe one of them is abandoned on the south side versus the north side of the road. And knowing that most of these would probably be backfilled with U-fill or that type of thing, it gives you an idea if you're trying to sneak a utility or a new sewer or something through here, really what you're up against or what you can do with that. And so at this point, it's really, now we're really starting to see the big picture of why this multi-channel can be something that's really, really good for us to utilize. So you can start to see this. And then what we can do is now is really where I kind of get excited for it, and where we can really go with it. Is now we can start taking these image files or the exported data and start to put them into the drawing. So this is now more of a utility drawing with the tomography information overlaid within it. And it's all spaced right. It's all georeferenced because we collect with GPS or total station, depending on the situation. So now that was the same area that we just kind of overwent. So now you can start to see, well, there's the trenches. So what it does is it allows you, for one, a quick QC of the data maybe you've collected already for your records information or anything else. So now you can start to see, now, okay, so some of the utility information was good. There was some missed utility information here. Maybe they were abandoned or plastic versus metallic, or maybe there's something that was getting on. You can start to see all the pits and information around the chambers. But what was really interesting for this on this one is we knew there was an abandoned water main on one side of the road. We couldn't pick it up. We couldn't figure out what it is. But based on all the pits and the connection points that we saw as we went through, we're able to now place it based on this information. So it allows us to realign information. It allows us to add information that might have been missed or we didn't even know about when we went there. Because from the utility side, when you're going out with typical electromagnetics, it always feels that you're trying to look for everything, but you kind of get stuck on what you know versus looking for everything all the time. And what I mean by that is, okay, we're going to do gas, water, hydro, bell, all that information, because you know it's there and you're going after it. But having this whole system go out, it's just picking up the data. It's not biased one way or the other. So now we can really start to pull together this information as we go. Same thing, this is just another section trying to show you, so now with the trenches, but what's really nice about this is the same idea. You can start to see, well, some of our QLD lines, we can start to realign. We can start to pick out different trenches and information. We can kind of concentrate on what we know. We can do a quick QC. Now we can see there's bigger trenches, so maybe that's important to somebody is, well, we want to know wherever there was excavations previous, wherever there's trenches, because maybe you want to stay away from it. Maybe you understand there's something. And even on this one, what was interesting is you can start to see this is on a base file. So this is there's an existing curb. Hopefully you can see my cursor. But we can also see that this road was expanded at one point in time, because you can definitely see the change in soil or below the road. And so this used to have been existing boulevard, and well, now it's been taken off, paved over, and pushed back. So we can see if there was any maybe utility information or buried infrastructure that could be there that could affect going forward, but didn't at that point in time. So you can really start to pull this information together and really see, it kind of gives you that big picture idea of what we're doing. So I'm trying to now relate it back to, here's some live examples of information that we do. So from those last couple, it really helps with utility specific information and what we can do it. And how that works is you can see on these ones, again, we've overlaid a base file. We have existing utilities and records, and now we start pulling the information in. And you can see on this is we just got an image, it's georeferenced correctly. And you can see that a lot of the utilities we did get, no problem. But now we can start to see areas where we didn't see these ones, and maybe we can realign this based on the electromagnetics. Maybe something was causing a change in the electromagnetics there, our normal pipe and cable locators. So now we can really start to develop and key in on, really showing the full potential of what's out there. So then it's the same image again, but we're adding in different lines. We're confirming locations, maybe repositioning locations based on what we know, adding total areas that we had no idea about, non-conductive, abandoned utilities that are out there, and taking it from there. So from a utility side, it really is a tool that helps us to develop this overall map of what's there and what we can do with it. So it's kind of key for us on that. So that's the one part is, okay, it can help us with our utilities, abandoned or alive, in our areas and what we need to do. Another big thing though, what I find is with the multi-channel, or what it's doing with these array systems, is the non-utility infrastructure that it's finding. So one of the things that I'm a little proud of, I guess, on the different jobs I've done, and it's really nothing to do with me, it just by chance and luck that I'm in the right spot at the right time, but is really looking for tracks. And it's funny with the amount of jobs that I've done over the years, and looking back and doing research based on the information I find, is how many locations or cities have at one point in time or the other had old trolley tracks that over the years have been buried and abandoned and just paved over. At the point in time when the road went in, they didn't feel it was needed to take out. So you start to get this information. So here's a job that we did, and it's just a little section that you can see in the middle, and I'll put it on. So again, the same thing is we can bring this image in. There's a topple that goes with it. And now we can start to see is that they've had to do some work on one side or the other, but there's a set of tracks that are buried within the roadway. It might, if you don't do anything in that roadway, that's fine. They can sit there. They're not causing voids or anything. But once you go and start to dig or come across those, it's going to be huge downtime and costs at a later point. So knowing that they're there up front, maybe you totally change your design or plan. So again, just going through some different ones. Again, here is a section where, you can definitely see the tracks. And I think in this one, we can see the ties, and the track itself was still there. And it related back to when we were doing our normal electromagnetics, because we had a couple of unknowns where were the actual tracks themselves as we went through, but we would never known the beds, or even if that was a railway track at that point or a trolley track. And again, here you can kind of see they're on one side of the road versus the other, and all this information can be overlaid within the drawing. So I'm just kind of putting through the depth slices. And then what we do is we can bring that image right in and put it on top. So now you can see there was definitely trolley tracks in the middle of the road. You'd never know that going out there now. And when they put the cross street in, they dug them out and removed them, but they didn't have to remove the other portions of it. So finding this information when we're out there is really key. And so where I said in the beginning, I've been lucky to be on the right job at the right time, or there's more of these out there than we even hazard to guess. But you can definitely see, again, here's tracks right in the middle. They're going right down. You can definitely see them. They're still even over top of the big culverts and bridges they have in the middle of the screen there. And then when it goes out, they've got them there. So now they know that there's an upfront cost for the removal and disposal of these tracks that they would never have known about from any design or planning point of view, other than if you've got, I'll say Fred at this point in time, just retired and remember that the trolley tracks are there and maybe something to look into. But all these ones so far is the majority of the time, the people don't realize that they're still there and under the ground. So this is just one last one I like to show. I found the 2 sets of tracks, no problem. You'd never know this. And I was actually doing some research because I just like to find out for myself. And there's an image of the same area showing it back in the day. So they're even horse-drawn trolley tracks that they used, and this was the setup, and that's what we're actually seeing in the picture. So it's, for me, it's kind of an exciting from that point. So even with the multi-channel now, it's allowing us to create these maps, these overall drawings that really dictate and show what's out in the middle of these roadways or these right-of-ways, to really help us kind of plan that going forward, so we know up front. Another part that we found in kind of more of the urban environment, and I like this picture here of the tree and the tree roots, is even tree roots are becoming more and more of an issue in certain areas, like the age of the tree or a certain park environment. So I just wanted to show some data that, again, the same idea from a tree's perspective. We've had to go out, we were called out to go do this one, and it's really to map, or how much issues would there be as if they were to open trench going through this area. So this was information that we could see and put together. All what you see on the screen, those are all the tree roots from the tree that they obviously couldn't cut it down, but they didn't know how much damage they would do to it. Using the normal 2D GPR, it'd be very hard to interpret this in the field. You'd have to do a lot of collections to gather that data, but by doing it with the multi-channel and the array system, it allows us to get all that information and pull it in. Again, a lot of it's on the processing side and doing the interpretation, but you can really see in this urban environment how the tree roots come through, and it really helps the designers to plan, okay, well, maybe they shouldn't go through here, maybe they should find a different area. Same thing, I'm just sticking on this urban environment area. So here's an area that was totally paved over. It's Google Maps in the background. It just looked like a nice parking lot, you know, park environment, that type of idea. But they had some kind of feeling over the past that there might have been buried old buildings in this area. Let's say it that way. So again, we went out and did a section of drawings. So as you can go through, you can start to see in certain areas, you can hopefully see the red arrow. That's buried footings and foundations from an old building. So there was an old building there at one point in time, but now it's been just buried in the area. So if they want to do any work going forward in the future, it'd be very tough to do. Funny enough, in the same area, you kind of go through, there's other buried concrete and rebar you can start to see and depict going through this area. So this is more of almost like a dump site than it would be a normal paved parking lot area. So it's all of a sudden really start to open light what happens. And then, you know, the final one here is, again, my typical, there's still even a set of train tracks that were going through. I think this was a spur line that they figured out, and we knew that was in there. So it's amazing once you get this information, you can always find more background information, but up front, it just looks like, oh, this is a normal spot that, you know, it's kind of almost untouched and what we can do with it. So in this little area, it's amazing what's actually in that spot. And then trying to go through and still kind of in the urban environment and what we're going to do, and more into what we did as project results. This is one that was very interesting to me. I gathered a lot of data, was given to me. It's actually mapping old cemeteries that have been in place that maybe have been removed or we're not sure of. So again, with typical GPR, the amount of time that it would take to collect the data to gather this information would be, it would take a lot of time, where, you know, now we're down to hours to collect the data and then processing it going through. So you can just see, this is just one, for instance. We do quite a few of these, trying to map out old graveyards. And again, this is on sites where there's buildings or over the years that they've changed. And again, the same idea is infrastructure has been built up all around this because people didn't know that it was there. And then throughout time, they figured out, okay, there's a location, or maybe there's something going on here, maybe we should look. So we're utilizing the multi-channel and then actually putting it in with LiDAR and trying to develop full models that people can, and to go with this. So it's pretty amazing what you can see and what you can get from this information, and then kind of take it from here. I always feel weird doing those old gravesite ones or cemeteries, because it's just always a little different, because if you find it, it's never good if you find them. So it's a different situation. And I'm going to leave on this one. This is a whole project that I'd like to go through. It's data that was collected for us actually down in Vegas. And of course, Vegas, it's always lights and showy, but we were able to get a lot of good information from this one. And so that's why I always like, it's an idea to show you in a right of way where let's be honest. Well, maybe not so much now during our COVID era, but during the normal time, the amount of people traffic, foot traffic, vehicle traffic, just everything that's going on down in Vegas was really hard to really figure out what we were going to do. So we were there to map kind of everything that's in the right of way. And so from you start off with the electrical, you do your records research, you do your electromagnetic, typical electromagnetic pipe and cable locating, but it's very hard to figure out everything that's in there. You're having to go at weird times of the day. The amount of people and vehicle, it was just unsafe to try to do that. So that's where I go back to where I was saying before, is you almost focus in on what you know is there versus really trying to look for everything that's out there. So this is an idea. I've got a couple of videos I'll show you just to try to pull it together, but there's a picture of us going down. What's nice about using these multi-channel or these array systems now is that you can pull them out. You can be in live traffic. You can go through, you can see here, we just have a safety vehicle behind us, but we're not having to shut down lanes anymore. We're not having to really stop traffic. A lot of people tend to think this is a Google Maps camera as we're going along, so they stop and start dancing and doing weird things. I don't ever correct them because it keeps me busy and funny, during the night sometimes, but it's pretty amazing what you can do. And again, here you can see we've got a safety vehicle behind us, but we've got the GPS running, so it's collecting data, and we're just kind of traveling within traffic. Even those cones and that construction, that was other construction that was going on at the time. So it doesn't really slow us down. And it seems like every day, every week, it's upgrading. So that system, for example, you had to go a bit slower just because of the way the data was collected. But now we're utilizing systems that you can go at almost highway speeds and collect data out there. So it's pretty amazing what you can do, and you almost never even affect traffic. This is a big tow behind. There's ones now that you can put just into the hitch of the truck and go, and you don't even really affect traffic at all, which is kind of great for us because it takes that safety component out and puts it onto this. You still need to do pipe and cable locating and everything else to pull the whole picture together, but this really adds a lot of example here. So I just because it was Vegas, we were allowed to get a permit to run a drone at night. Again, we didn't block any traffic, but I'll just kind of show you. It's a quick little video clip that you can see. So this is just us traveling. We're actually collecting data as we go. Part of our permit was we had to have a safety vehicle behind us just because it's Vegas and away we go. But you can see that's us collecting data at that speed. And the full swath is almost doing the full lane of the road. So really depending on what you're trying to get out of this product at the end, it's pretty amazing what you can see and what you can get from that. So a little clip to show you how it collects the data. The next one here is everybody, we're always making it look good. So here's the same idea. It's in Vegas, the same section that I think you just saw, but we put a GoPro on the back just because everybody wants to really see what this is all about. And like I said, collecting the data you're really just driving. You're just collecting data. There's really nothing fancy to see. So to try to show that, we have to go in this regard. So this is just a GoPro we put on the back. But again, you can see we've got the safety vehicle behind us. We're in and out of traffic, turning lanes. It doesn't really stop us or slow us down anymore. And we can collect this data, and then we can turn around and collect going back, and the same thing coming back again. And it doesn't really take us very long to collect all that data as we go. And so this is what we did in Vegas. And as we went through, just to kind of show you where we collected data, this was the intersection that we were at. I was able to find an old Google Earth image. This is kind of before Sands Avenue and Vegas Boulevard, there was anything there. You can see it's a very grainy picture, but in the background, there's no information there. It's just some of the old, I think, casinos maybe, but not much there. So that's kind of what's in the past versus the present. This is what it looks like today. That's the exact same intersection. Big buildings, casinos, huge roadway. So how do you really undertake to get this information? They're really trying to design to put new water mains and sewers in. So where do you take this information? So what we did is kind of the same process. We started off with a QLD drawing. We pulled whatever records we could together. This is what we're getting here. So that's just, if anybody knows the SUE process, this is the QLD collection. This is just pure record information. Whatever we could find, kind of put it on a record. So we've kind of collected it that way. And what I said before is now we've gone, here's the QLB data on top of that or with the QLD records. So we've gone out and used electrical pipe and cable locators to find the information, surveyed it, and put it on the drawing. But it goes back, you almost look for more of the information that you know about from the records you're trying to find unknown information, but you're trying to pull it all together in the middle of a busy intersection with all these people and lights and everything else. So it makes it very difficult, but then there would be our QLB information. So then we brought in the multi-channel and we thought, okay, how do we make this better? So again, the same idea. Here's what we did is the pass. So it's a huge intersection. I think it was like 6 lanes in either way. So quite a few paths to get it, but it wasn't even a night of collection. It went fairly quickly for us. We were able to collect the data. So it just shows the outline of the collection areas that we went. And trying to pull this all together as information to be as safe as possible. So what I'll do is, so now it's the same intersection, going back to those depth slices that I showed you earlier. And as you can go down through, now you can really start to pull the information together. So I'll probably try to run this twice, but you can see these are different slices going down through the earth, if you want to say, at different depths. You can see different utilities coming through, different structures, different abilities to see information, a lot of information that we would have never got or received before. And what we started to figure out is there's a lot of abandoned infrastructure in Vegas. They just kind of put in new, and I didn't think there would be much in this area because typically in Vegas, they put a lot on the side streets, not down Vegas Boulevard, but over the years, a lot of information went through. So this is just one component of what we developed to help us pull these drawings together and get this information. So you can see here, we start to pull this information together and pull the information out, and it really gives us that overall map of that area utilized with our pipe and cable locators, because that allows us to depict, well, this is a water main or this is a sewer or a gas line, where with typical GPR data like this, we'll never know that's what it is. We would just know that there's something there. So it's definitely a tool hand in hand to go with it, which allows us to get through. And then so kind of now the end product is, this is with QLD with the record information right through to our QLB and the multi-channel. And you can see there's a lot of information that we never would have even known was there from beforehand, just based on the pipe and cable locator and the records information. And then kind of our end product now as we put it out, and now we can see there's all the information that we received from the pipe and cable locators, plus maybe a lot of unknown information that we didn't even know about was out there, but we were able to find now or try to put through, so further investigation can take place to help out with that overall deliverable or what we're trying to do as an overall. So I've kind of hopefully taken you through single channel, the normal 2D interpretation in the field right through the multi-channel, and how it's really just not all about utilities. It definitely helps with that and what you're trying to find out there, but it really helps when trying to find all the unknown structures. Like I said, everything from tracks to graves to abandoned utilities, abandoned infrastructure, just even to garbage and debris. It really helps bring that all through. So hopefully I was able to get through that for you today and answer some of those questions. And like I said at the end, just some of the benefits that we're finding we're utilizing this information is, it's a great double check of information. You can put those screenshots or those depth slices right on top and start to QC whatever it is you're looking for, from tree roots right through to utilities. It'll help you align and help further find stuff that was maybe never found in that base investigation. It's an independent evaluation. What I mean by that is, it's not biased. It's not the person in the field. We're just collecting the data, and then we can do the interpretation, the processing behind. And then it really helps with the elevation and collaborating if you're doing test hole information on depth, because you can really get depth information from this and really take it from there. So hopefully I didn't go through that too fast or too slow or it was boring for anybody, but I want to thank you, and please stay safe out there, especially with everything that we've got going on in this day and age. And if you have any questions or concerns, just don't hesitate to reach out. I'm assuming that my information will be put out, but there's my email if you want to jot it down, or even my cell phone. By all means, please give me a call and or an email, and I can send you some information or anything else that you'd like to learn about with us.
Perfect, Jamie. Great presentation. I think basically we know it's a great presentation because we started with about 77 attendants, and right now we're at 73. So you really kept everybody hanging in there.
Woo!
So, in terms of questions, we do have a few if you got a few minutes.
Oh, by all means, yeah. Do you want me, sorry, Mark, before you get, do you want me to just leave it like this, or do I have to stop sharing or something?
No, that's perfect, Jamie.
Okay.
That's really good. So one other thing, actually, Lori's going to run a quick poll. So if all the attendants can if there's going to be a poll that pops up. If you can please answer that quick survey while we're going through these questions, it'd be greatly appreciated. So Jamie, a few questions for you. Can you give one example where the GPR investigation outcome exceeded client expectations and another where it did not achieve the expected results?
Yeah, I'll go where it did not first. That actually happens quite a bit. So even that we're using these array systems, these bigger systems, it's still GPR. So it's very dependent on soil conditions and information. So we did one where it was very clay-based underneath the roadway. We were trying to find certain utilities, and because it's GPR at the end of the day, it could not penetrate. It could not see that information, and you just have to walk and say there's limitations to everything. I wish I could see everything, but that would be a key structure where we just couldn't help out because of the conditions that we were up against. But that's what has alluded me to more of the trenches and trying to manipulate that. The one that would be good is, I say, finding these tracks. I know I went through that a few times, but it's always exciting when you find something like that and you put it to the client, and then they get very excited because now it's they know up front and what they can do about it. So that whenever I find a track, I always find it, I'm excited and the client gets excited. Maybe because I'm excited, I'm not sure.
Okay, great. Next question. When using GPR data to feed into the composite utility plan, what quality level do you basically assign the information you obtain through the GPR investigation?
Yeah, so that's a good question, and we go back and forth on that. So a lot of times, if we don't know what the information is that's coming through, so if it's utility specific because it's a linear piece of equipment or a linear information, we know it's probably utility specific. We can put it at probably a higher quality level, say a QLB, because it's surveyed information, it's continuous, and we know it's something there, but we might put it as an unknown with a type of note on it to say that we believe this is a water main or a gas main. Because the information is, georeference, it's good that way. But it's always that without utilizing that with electromagnetic, sometimes we can't tell you what it is other than that there's something right there.
Okay.
Sorry, I think that answers it.
No, I think it does.
Yeah.
Absolutely. How do you, oh, sorry, just slid. How do you account for any distortion when working on slope surfaces or more uneven surfaces?
That gets very difficult. A lot of times when you're using the multi-channel, it's got to be more on a flat surface. There's different ways when we process the data. As long as we know and we're collecting with GPS, it does help us. So we can make those corrections as we go. A lot of times we'll just know that and understand that and do the correlation. It's all kind of with the multi-channel. It's all done outside of the everyday or outside of the field. We collect the information up front, we kind of put it through and we help us go through on that. But there's a fair bit behind that to make sure that what we're seeing is georeferenced correctly where it is. So there's a fair bit behind that, especially when we're surveying.
Okay. And here's a fun one. What's the cost of this information? So I don't know, maybe you could do kind of an average daily rate or something like that. That's the question.
Yeah, no, it's good. So I mean, it really goes all over the place depending on what you're looking for. But it's more of the daily rates. If we've broken it down into different categories. So if it's like say a category 1 where you're just looking for image files or something basic, it'd be just a daily rate. So maybe it's collecting the data and processing anywhere from 2 to 3,000 on a daily rate. If you're doing more data interpretation and really getting in depth and creating these 3D models, it's all in. It would probably be with collection and interpretation, maybe $4,000 or $5,000 mark just on the daily basis. But that's all in. So it's kind of really dependent on what it is we're looking for and how it's being used for that.
Okay, thank you. Here's one regional specific. Why in Quebec is it not successful more often than not? And Gatineau example is what's typed here. So you may know.
I think I probably even know what that one is. So that would be one where I was even disappointed on. But Quebec itself, and it depends where you are, is very clay based. The soils themselves are highly clay content, and GPR just does not work very well in clay at all. The conductivity of it just absorbs that data. We can't penetrate deep. The array systems help us a little bit in situations like that, but that's just for some reason, the content of the clay that's there is just so high that GPR just does not work very well out there. We can start to interpret and see trenches or where areas that are dug, so the differences in, say, clay content, but the actual see the utilities or that information is, I'll be honest, I try to stay away from there if I can, just knowing that up front. It's a hard one to deal with.
And I think that's probably consistent with the way you approach clients, right? If there's areas where you know that's clay-based, you probably come out with that knowledge up front.
100%. I mean, and I've done it for enough years and covered a lot of the areas, so I kind of know where some of those areas are, and we're upfront about it. I mean, at the end of the day, depending on what you're trying to find, we'll be honest about it, and maybe we'll do a bit of a trial or a spot to see it. But yeah, it's oh yeah, for sure upfront, because it doesn't help me or anybody if we get out there and can't find anything anyway, and we knew that up front for sure.
Okay. Thanks for sticking with us. There's still a few more questions, if you don't mind.
Yeah, by all means.
All right. So next question is the MCGPR a default for T2 UE investigations against the electrical magnetic investigation? So I think the question is it a default versus the typical electromagnetic investigation? I think I'm reading that correctly.
Yeah, I would take it that way, Mark. If that's the case, then no, it's definitely not a default of one over the other. We're finding that it's very, like I say, it's a tool in the toolbox. It's very, they go hand in hand very well. You need one almost with the other, and it's very specific to the project. If it's a big right-of-way project where you're doing kilometers on the road, it's worthwhile to really do it. If it's trying to map out one little utility in an area, you might not go this far, but we're trying to utilize it more and more just because of the information that we can gather from it. But no, one will not overtake the other for sure.
Okay. And here's a good one. How deep can you reach with MCGPR?
It's the same thing. It almost goes back to the Quebec question. It really depends on the soil conditions and what you can do. In some areas where we're down, they're collecting data, and I'll say the southern states or in Florida, they can get down 15, 20 feet and see pretty clear. Up here and in certain areas, maybe we're getting 5, 6 feet, maybe 7 feet tops. It's just because of the clay content and what we're up against. So it really changes from where you are and how deep you can go.
Thank you. Is the GPR accurate to measure cavity volumes?
Good question. I don't know what the accuracy would need to be on that, and depending on how good the data could be, you could definitely get volume information from it. I haven't done that. I'd have to look into that a bit more for sure. Okay, very good. And whoever asked that question can definitely reach Jamie. By all means, yeah.
Absolutely. And can you talk about the differences why in BC that use the first tool? So I'm not exactly sure what this means. So perhaps in BC they use GPR as the first tool.
Yeah. Sorry, Mark. Yeah, I think I understand that. They utilize GPR a lot out in BC or in the West, and it's because it works very well in BC. The soil conditions are right. The utilities aren't super deep. So everything just kind of goes very well with that. So I think their first choice were here. We use typically electromagnetics first. They would go to GPR first just because of how well it works up there.
Okay. Very good. That concludes our questions for today. Thanks for sticking with us, Jamie. We really appreciate the presentation. There were a couple more comments that came in just saying great job. So kudos to you. As everybody can see now on the screen, I've got the wrap-up slide. Just mentioning that this coming Thursday, we have Digging into Late Locate Solutions. That's Jeff Hitchcock from Ontario One Call providing that presentation. I think we all have a very interested stake in that call. And I would like, again, to remind everybody that the Right-of-Way Management Committee is always looking for industry involvement. If you're interested, please email info@rightofwaymanagement.ca. And once again, thank you, Jamie. Thank you to everybody who participated in today's call and joined. We look forward to seeing and hearing from you again. Have a great day.
Great. Thanks, Mark. Thanks, everybody. you still there?